Good morning, everybody. Hopefully you guys are doing all right today. Start with some green check marks, make sure everything is working, and then I'll talk a little bit about what we're going to go through today. Then we'll have some time to work, and we'll go from there. I might just add, Friday we went skiing. So much fun. I had just a great time. It was nice and crisp and brisk up in the mountain, and there's lots of good snow and some good falls, and it was awesome. So if you're thinking about coming skiing again, then yeah, next Friday would be great. We're gonna have an instructor again, and be lots and lots of fun. So Taylor has some questions from Unit 8, which is good. I see everyone's giving me a green check mark, which is terrific. That means hopefully everyone's with me. The Unit 8 material is all kind of done. I know we did it a little bit differently where we pre-recorded the lesson, so I'm sure you might have some questions. If you do, you can just throw them into chat and I will go through them. And basically, I think I had scheduled, or just thinking about the unit, I wanted you to finish up Unit 8. I think the learning guide today, and then the test sometime either today or tomorrow. And then we do have the unit, or I guess we called it a math midterm, which is going to be a week from today, January 18th at the Central Gym from 9 to 11, just like the first one we did. Except this one's kind of all the material instead of just, the first 4 chapters. And it's going to be kind of focused on the units 5, 6, 7, and 8 with a little bit of stuff from 1, 2, 3, and 4. So we'll talk about that here in a second. Taylor's thrown in a question from the learning guide, and I would be happy to do that, or so there's a few there. So we can go through those. And then anything else, a few people had already written the test. They'd submitted the learning guide already and written the test. So I'll try to point out some maybe tricky things. The questions are asking to find an angle or a ratio, depending on how the question's kind of worded, depends on what it's expecting of you. So we'll try to clarify that because there was a little bit of confusion with regards to that. So let's jump over to the learning guide. Taylor asked for page 5, 3C, 6, 5A, and page 10, number 13. So let's jump to page 5, 3C first. 1, 2, 3, 4, 5. 3C. So this is in the using trig section, and it doesn't tell us which trig function to use. So we just need to figure it out based on the information we're given in the problem. So let's start by identifying our angle. We're given the 27. So every time we do a trig type question, you're either going to be given an angle or asked to find an angle. So we're going to measure all of our sides from that angle. So I always like to go across right away to find the opposite side, straight across from the angle. That leaves the longest side in the triangle as the hypotenuse, and then the bottom in this case is the adjacent. So we're asked to find units for the adjacent side here. We're also given the hypotenuse. So we need to use those 2 pieces of information to first identify the trig function we're going to use. And then from there we can plug the information in and find the length of that missing side. I don't need the opposite. I'm not given it, so I'm just going to kind of ignore it. So moving on to SOHCAHTOA. Which ones am I going to need? Well, I have the adjacent and the hypotenuse. So that means I'm going to use my cosine. So I'm going to take the cosine of the angle I'll just write theta for now, is the length of the adjacent side divided by the hypotenuse, the length of the hypotenuse. Now I'll plug information I need or want to find in, or things that I have. I know the angle is 27, the adjacent side is x, and the hypotenuse is 15. Now from here, I'm just trying to get x by itself. So remember this cos 27? That's just a decimal number. It's just a ratio of sides. I could plug it into my calculator and get the decimal if that makes me feel better. Or I can just think, okay, I have 15 on one side on the bottom. I want to get rid of it. The opposite of dividing is multiplying. Those go away. And now I just have 15 times the cosine, 27 degrees is x. And if I plug that into my calculator, 15 cosine 27 gives me 13.36, or 13.4 is the length of side x. And no units, so I just can write 13.4. All right, so that was the first one. There's a couple more here. Page 65A and page 10, number 13, I'll get to those. Abby, yeah, if you have questions from anything that we've done all year long, this is kind of the time where I get scared as a teacher, because you guys can ask me questions from anything and I gotta be on it. Alex, I didn't look up Klein bottles. I'm thinking it's just never gonna happen. Maybe today. I don't know. Maybe during science sometime. That seems like a better time for Klein bottles, maybe. All right, so the next one was page 65A. So let's just scroll down here. Page 65A, determine the value of theta. So we're trying to find the angle in this question. The previous question, we were trying to find the length of a side. Now we're trying to find the measure of an angle. So anytime we're trying to find an angle, we always have to use the inverse, or the -1 on your calculator. So let's see what that looks like. Every trig question, we're either given an angle or asked to find an angle, and from that angle we measure all of our sides. So here's our angle in the top corner. That makes this the opposite. This is the longest side, so that's my hypotenuse, and this is the adjacent because it makes the angle with the hypotenuse. What information don't I need? Well, it turns out I don't need the hypotenuse. I'm not given it, and I'm not asked to find it, so I don't really care about it. I have the opposite side, and I have the adjacent. So I'm going to use those to figure out that angle. So going back to SOHCAHTOA, opposite and adjacent, that's going to be TOA, tangent of the angle. Theta is the length of the opposite side divided by the length of the adjacent side. And I can go from there. Plug the information I know in. I don't know the angle, that's what I'm trying to find. The length of the opposite side is 12, and the length of the adjacent side is 5. So I can go 12 divided by 5, figure out what that ratio is, 2 point something, or I can just leave it like that. And because I'm trying to find the angle, I have to use the inverse tangent function on my calculator. I have to let my calculator know I'm trying to find the angle. I'm not giving the calculator a ratio, I'm giving the calculator a ratio, and it needs to give me the angle back. So if I take the inverse tan on my calculator, I go second tan. And then I can go 12 divided by 5 in brackets. Maybe I'll just bring that up. So that's what it looks like on my calculator. I go second tan, 12 divided by 5. I put it in brackets. That way I don't confuse my calculator with order of operations. And it tells me that it's 67.38 or 67.4 degrees is the measure of the angle. And that is it for number 5A. There was one more question Taylor had. Page 10, number 13. I think it's one of the word problems probably. 11, 12. Now, I don't want to say that this one is going to be on your final exam, but they love asking this question. It happens a lot. So one interesting thing about it is, depending on the information you're given, sometimes you don't even need to use any trig. You can just simply use the Pythagorean theorem twice. So let's see if that's the case here. It's two triangles. All of the two triangle problems have a shared or common side between the triangles. And this one is no different. It's only different because it's in 3 dimensions. Instead of everything kind of being flat in 2 dimensions, you have a triangle on the bottom, and then you have a triangle that's kind of vertical. So let's identify the triangles we're dealing with here. I have a triangle here in blue across the bottom and along the diagonal there. So I'm going to redraw that triangle right next to my picture here just so I don't get too confused. I have a 90-degree angle in the corner here. I have 50-degree angle up here. I know that this is 24 inches long, and that is the first triangle. The second triangle I have is this red guy with my diagonal along here, and I'm going to redraw that triangle. Now this is the A, B that I'm trying to find in the question. I'm given that this is 9, and that's the only information I'm given in this triangle, is the fact that I know that this is 9 and I'm trying to find this side. I don't know any angles. I don't know anything else. So what I need to do is use the fact that these are shared sides. So what I'm talking about by a shared side is the hypotenuse of this is the same as the base of the red. So if I can find that yellow side up here, I can call it X. If I can find it here, I know that it's going to be the same length, and I can use it for down here. It's the same thing. So once I find that shared side, I can use that information to find the missing side that I'm looking for, the diagonal AB. So let's solve the blue one first, and then from there we can go ahead and solve the red one. All right, looking at the blue one up here, I'm given the angle in the top corner here is 50 degrees. If I go across, this is now my opposite side, and this is my hypotenuse. I'm not interested in the adjacent because I don't need it, and I'm not trying to find it. So what I'm going to do is think about my trig functions. I have the hypotenuse, which I'm trying to find, and I have the opposite. So opposite and hypotenuse is the sine. So I'm going to take the sine of my angle is the length of the opposite side divided by the length of the hypotenuse. In this case, the angle is 50 degrees, the opposite is 24, and my hypotenuse, I'll call it X. Now we've solved a few of these, and skipping 2 steps, you'll know I end up with X is equal to 24 over sine 50. If you don't believe me, you can do the steps by multiplying by X and then dividing by sine 50. Let's figure out what that side is. So 24 divided by sine 50 gives us 31.3. In this case is inches. So I'll keep 1 decimal place, that should be good. So now that I've found X, what I've found is this, the hypotenuse of my blue, which is actually the base of the red. So now that I know it, I can just take that piece of information and bring it down to this triangle down here. And from here, I can just use the Pythagorean theorem. I know that this side is now 31.3. I know this side is 9. That's 2 sides of a right angle triangle. I can figure out the third. So what I'm going to do is do just that. This question mark here, this is AB. I could call it whatever I want. Maybe I'll call it AB. So I can have AB squared is equal to 31.3 squared plus 9 squared. Now I can't do that in my head, so I'm going to have to use my calculator. So I get AB squared is equal to 1062.55. I want to figure out what AB is. I'll take the square root of both sides. So the square root of my answer was 32.596. We'll call it 32.6. And we are given units of inches. And there we go, so 32.6. I guess it's a bit tricky, kind of determining what's going on in the question, but nothing we haven't done. Pythagorean theorem, the couple trig, like one trig function type step, 2 steps. So basically all of the word problems will involve 2 steps. Generally speaking, they'll have 2 triangles to deal with, find the shared side, and then from that you can use that to solve the other half of the problem. So hopefully that helped, Haley. Was there any other questions from Unit 8? If there wasn't, then I would love to go on to the next topic, which was kind of review. Can you go over question 14 on page 10? Always. I always show my work. I guess I skipped 2 steps in that last problem, so maybe not always. Maybe I just lied. Sometimes. But yes, I strive to show my work whenever possible. So that's kind of it. Maybe somebody has another question, page 9, number 11. Anything else other than this guy? This can get a bit tricky. I tried to draw a picture. I forget whose work, I think it was Savannah's. She had these like beautiful diagrams and I just wanted to, just copy them and include them in my lesson. Some people are artistic. People like me are not. Here's our building. There's some windows. That looks like a building. And it says the building is 53 feet high from top to bottom. And we're asked to find out how far the person is away. We know that at 6 feet above the ground, the angle of elevation to the top is 43 degrees, and we want to figure out where this person is. So I guess the trick, not necessarily a trick in this question, but the step that a lot of students miss is the fact that this person's eyes are 6 feet above the ground. So if I draw my triangle here, which I have, I know the whole thing is 53. Well, my triangle on this side only has a height of 47 from here to here. So that kind of changes my diagram a little bit. Now, sometimes once you've drawn a picture, everything kind of gets all jumbled up and it's kind of hard to figure out what's going on. So if it makes sense, you might want to just redraw the triangle just to get a really simple picture of what's going on. I'm trying to find x. I know this is 43 degrees and I know this is 47 feet. So what am I trying to find? Well, I'm trying to find this side, which is the adjacent. This is the opposite. And this is my hypotenuse, which I don't need. So I'm going to take the tangent of 43 degrees is the opposite divided by the adjacent. I am going to switch them, so 47 divided by the tangent of 43, and I should plug that into my calculator. It's 50.4, and in this case this is feet. So there we go. I'm thinking I've probably done almost all of the questions from the learning guide, so I should probably leave a few for you guys. If you had any other questions, though, I'd be happy to look at them. Prime factorization, least common multiple, and greatest common factor. Yeah, that is stuff that kind of gets a bit tricky. Be happy to do that. Question 12 on page 9. Question 12, page 9, done that. That would have probably been maybe Thursday last week. Should be up on the website. Solutions there. Again, two triangle problem. The key is the shared side in the middle, which is the bottom of this green guy, and top of the green guy and the bottom of the blue guy. So you need to find the length of that. You don't need that, but you needed to solve the two triangles, and then you can find the two opposite sides, and from there you can add those together. Wording of number 6 on page 7. Draw a label, a right triangle, illustrate the trig ratio cos, then determine the measure of the angle. All right, we know that the cosine of an angle, we don't know what the angle is, but cosine is always the adjacent over the hypotenuse. So in this case, we have 7 over 18. That means if I were to draw a triangle, the adjacent side has a length of 7, and the hypotenuse has a length of 18. So that is how to get that one started. One thing that kind of comes up on tests and quizzes is that sometimes it asks for the cosine of an angle, sometimes it asks for the ratio of sides. It just kind of depends on the problem. So if I were to go right up to the very beginning, things we did, these are all thetas. Says, given the ratio, determine the angle. So this question's asking us to find the angle. So we need to figure out theta equals something like these questions. You're given an angle and asked to find the ratio. Now, if a question says, what is the cosine of A? And then you're given a triangle like this. You have your angle down here, call it A. And let's say this is 13, and this is 22. Now, when it says find the cosine of A, what is this question asking us to find? Is it asking us to find a ratio of sides? Is it asking us to find an angle? What are we actually trying to do when it says what is the cosine of A? This is where this section, although you may know what's going on and may know how to use your trig functions, it gets a little confusing because you're not sure what it's trying to find. In a question like this, it's not asking to find the angle. You don't want to go A is equal to with some angle. That's not what it's asking. If it says what's the cosine of A, you're going to be a smart student and say, okay, cosine is the adjacent length, so 13 divided by the hypotenuse, 22. And then you go to your answers and 13 over 22 isn't there. So the next thing you try is 13 divided by 22. And that's 0.5909. So you just go with that and see if that answer's there. So unless it explicitly is asking for angle A, if it just says what is the cosine of A, it's probably, not all the time, but usually looking for a ratio of sides. If it asks specifically for the angle, then you need to find the angle using the inverse function. But in this case, this type of question, it's only asking for the ratio of sides. It's not asking for you to determine the angle. So just kind of be careful a little bit when you are doing the test or the quizzes. Just slow down and think a little bit about what it's trying to find, or what it's asking you to find, I should say. Is there anything else from Unit 8? That's kind of it for Unit 8. I think we've probably covered just about anything. If something comes up, we can go over it tomorrow for sure. I don't have any issues with that. I know Abby had some questions about LCM, GCF, prime factorization, which I'll go through. And I just wanted to kind of let you know what we're going to do for the next few days. So, of course, a week from today, we have our midterm number 2, and you're going to need to start reviewing for that. And there is a learning guide for it. You'll notice this learning guide that we just went through was 10 pages, and that is 1 unit. Now, in the course, I think I actually have it up here. If I go down to the bottom of Unit 8, there's Unit 8, all of our lessons. Final exam review package is here. So if you click on that, up opens another window and it says, here you go. So this is the final review learning guide. And this is probably what I'll spend maybe a day or two talking about. We don't have a ton of time, but just some questions for you to go through. You'll notice that this is the whole course in 10 pages. So Unit 8 learning guide, 10 pages long. The entire course unit guide is also 10 pages. So there's no way that every possible type of question that you're going to encounter is going to show up in this learning guide. So just be aware that it's kind of, picking kind of highlights or little pieces of all the units we've done. It's not inclusive of everything. So don't think, I've gone through that whole Unit 8 learning, or the whole final exam learning guide, and then I'm good to go for the final and the provincial. You probably have a pretty good grasp of some of the major concepts, but not all the information's there. So just be aware of that. I don't want anybody to be disappointed. So we have finished Unit 8, assuming nobody has any further questions. We have class tomorrow, Wednesday, and Thursday. So we have 3 classes. I would like to go over a practice exam with you guys, question by question. Now that'll probably take about 2 classes. If I'm going super duper fast, I can usually get one done in about an hour and a half. So maybe Thursday's class, I'll see if I can go through an entire exam. So what I'll kind of roughly schedule is this. Tuesday and Wednesday's classes, we will spend some time looking at the final review learning guide behind me, and or anything that you might have questions about. So if you have questions, you're going through an old provincial exam and you see a question, you don't understand how to do it, then I'd be happy to go through that with you. Any questions that you can come up with. If it's something that I might not have access to, or I might not have loaded into my little OneNote program here, if you send it to me beforehand, I can find it. Or if you can just send me a little picture of it, I can bring it up and then I can do it for you. So that is kind of what we'll be doing. So 2 classes we'll spend looking at this final review learning guide. On Thursday's class, I will spend the whole class going over an old provincial exam, and I'll make that available to you guys today. I'll upload one of my favorites, and we can go from there. Is there still math help on Wednesday? Yes, there is going to be math help on Wednesday. If I'm not available, somebody will be, and then we can have help. There's, usually at least 3 teachers in the building who can help you with some math. I'm always available for at least an hour of it. Sometimes I might have class to go through. It just depends on what my planning classes are doing. So that's kind of what we're going to cover for the next few days. Now, Abby asked specifically about the greatest common factor, least common multiple, and prime factorization. And then I could go through anything else. We don't have a ton of time, probably, take up the rest of our day here. Abby, can you remind me which unit that is, which unit and lesson, just so I can kind of refer to that, and then maybe we'll look at a few examples. I think it was I want to say unit 1, but I'm not entirely sure. What was unit 3? Dividing terms with exponents. No, not unit 3. Does anybody remember which lesson we did? Might be unit 5. Everything's kind of a bit of a blur at this point. Unit 4. That's because we talked about the greatest common factor when we were factoring. Alex is unit 4. Alex is right. Just need to find the lesson now. I know we've already gone through the stuff in the lesson, which isn't going to be a huge help, but it'll give us something to work from. Perfect. All right, so it was lesson 4, unit 4. Okay, so we need to find the greatest common factor of 2 numbers. So there's 2 sorts of words that came in here, factor and multiple, multiplying and factoring. We need to remember that when we multiply something, if I multiply 2 times 4, that's multiplying. Another word for multiplying is expanding. 2 and 4 together expands to give me 8. So that's moving kind of forward or kind of down your page. If you think about factoring, it's moving completely backwards. If I said factor 8, you could go and break it down into 2 and 4. So when we deal with the types of questions we do in Math 10, students always get factoring and multiplying they just get really confused when they talk about factoring, because all of a sudden we're factoring things with variables in it. We're factoring trinomials and binomials, and it just kind of gets jumbled up in our brains, which is fine. So when it asks for the greatest common factor of 2 or 3 numbers, the easiest way to think about it is what number kind of divides, the biggest number that divides into both numbers or all 3 numbers. And we can prime factor the numbers to figure out what the GCF is. So just like the word greatest common, when we do a prime factorization, we're finding the thing that's common to both of them. So the example that we included here was 126 and 144. So if we take all of the factors of 126, we started with 126, and we say, okay, what can I break 126 into? So 2 and 63. 2's prime, so I just leave it. 7 and 9, 7's prime, so I leave it. And they get 3 and 3. So what did I have? So this is a prime factorization or a factor tree for 126. I had a 2, a 3, a 3, and a 7. And then I do the same thing with 144, and I end up with a 2, a 2, a 2, a 2, a 3, and a 3. Okay. So when I'm asked to find the greatest common factor, I just want to figure out what's common to both of these prime factorizations. They both have a 2, they both have a 3, and they both have another 3. The 144 has a bunch of extra 2's that I'm not interested in because I don't have them here. They're not common. And then the 126 has a 7. So what was common to both? 2, 3, and a 3, and 2 times 3 times 3 gives us 18. So the greatest common factor between those two things is 18. So that's kind of the first thing. Let's pick some random numbers and see if we can find the GCF of them. Let's get a new blank page here. I don't know. Somebody throw a number into chat and I'll pick another one and we'll figure out what the greatest common factor is. Let's go with a 2-digit number. Any 2-digit number bigger than 50. Let's make it interesting. Anyone want to? First one in wins. 60, I love it. All right, 60, and let's go with 135. Look at Taylor and Abby, both in the 60s. I like it. All right, so 60 and 135, just two random numbers. We want to find the greatest common factor of these two things. Now, just looking at them, I know 60 and 135 are both divisible by 5 because they end in either 0 or 5. So I'm thinking it's probably going to be 5. It might not be. There might be a bigger number, but let's find out. So what I'm going to do is I'm going to do a prime factorization of 60. There's 100 different ways to do it, but I'm just thinking 60 in my head. That's going to be 2 times 30. That gives me 60. And then I'm going to break my 30 into 2 and 15. And then I'm going to break my 15 into 3 and 5. So I've made a factor tree of 60. So the factors of 60 are 2, 2, 3, and 5. If I multiply those all together, I end up with 60. Alex, I don't remember that rule, but I'm sure it's there somewhere on the page, so you could go back. All right, 135. Nothing pops into my head other than 5. So I'm going to go 135 divided by 5. I'm just going to do it on my calculator. I get 27 and 5. Okay, I know 27 is divisible by 9. So I get 9 and 3. And then I get 3, 3. And 3 times 3 times 3 times 5 gives me 135. So 3 times 3 times 3 times 5, that's 135. So I can go from there. So now I'm looking for the greatest common factor. So what's common to both of these things? What's common to these factors and what's common to these factors? What do they both share? Well, I guessed 5, so yep. Sure enough, they do both contain a 5. What else do they both share? What's common to them? Well, this one has 1 3, and this one has a few 3s. So I get a 3 and a 5. So my greatest common factor is 3 times 5, or 15. Now, Abby, you'd asked a question which brings up a really great point. It says, for prime factorizations, can we write down 2 times 2 as 2 squared? Yeah, for sure. So if we were asked to do a prime factorization of 135, I could write it as, color here, I could write it as 3 cubed, because there are 3 3s, and 5. That would be a good prime factorization of that one. And then same thing over here for 60, I would write this as 2 squared times 3 times 5. So those would be my prime factorizations. This is kind of an or thing. You could write it either way, but likely on a provincial exam, you're going to see it this way. This is a little bit more common with the sort of exponent there. All right, so is everyone kind of clear on GCF and prime factorization? That's the easy part. The LCM, or least common multiple, that's when things get a little bit tricky because we're not used to dealing with it quite as often. Let's see if I'm understanding this correctly. The prime factorization and factors of a number are different. Factors of a number are the multiples of that number. That's correct. So for instance, so the prime factorization of 60 was 2 squared and 3, that's prime factorization of 60. If I were to just factor 60, remember factoring is what numbers can I multiply together to give me 60? So I could write it as 12 times 5. That gives me 60. That's factoring 60. I could write 60 as 6 times 10. That works as well. I could go 60 times 1. So these are all factors of 60. I can continue on with that process. So these are factors of 60, which are different than the prime factorization. These things are not equal. So the prime factorization and factoring are different things. With the prime factorization, I need to end up with prime numbers, things that can't be divisible by any other numbers. When I'm just writing factors, when I had something like 12 and 5, well, I can factor 12 further. So it's not prime. So those were kind of the first parts of your question, Abby. Hopefully that's a little bit more clear now. Factoring is just a list. I guess in Math 10, we write it as a list because when we factor trinomials, if my AC method or whatever, my middle number was 15, I'm going to write it as a big long list because then I'm going to add these together. So I'm going to get 1 times 15 and then 1 plus 15, 16. I did it in kind of a list format because it's just easier for factoring these numbers when I have to factor a trinomial. So it doesn't necessarily have to be, well, I guess it is a list. I could write a list vertically or horizontally. I suppose that's correct. There's nothing wrong with that statement. Okay, so that was the GCF. The LCM, least common multiple, is a little bit different. Then we discussed this during the class. There's 2 different ways to find the least common multiple. So I'm going to start with a couple really small numbers to demonstrate how this works. So if I'm finding the least common multiple of, I don't know, let's pick 12 and, I don't know, 10. Let's make it really easy for now. The M in LCM is multiple. So if I started with 12, what are the multiples of 12? Well, you can think of it this way. I probably wouldn't write it out this way, but I could go 12 times 1, that's 12. So 12 is the first multiple of 12. What is the second multiple of 12? I could go 12 times 2, that's 24. That's the second multiple. Okay, I can go 12 times 3, that's 36. And I can keep doing this. And keep going, 72. I can just keep going. These are all the multiples of 12. Think about it as counting by 12. Okay, so I can do the same thing with 10. 10's a little bit easier, and I picked it because I knew it was going to be easier. 10 times 1 is 10, 20, 30, 40, 50, 60, 70, 80. So if we think about what LCM stands for, it's the least. So the smallest, that's what this is, smallest. C stands for common, and then multiple. So the smallest multiple that both of them contain. So if I look at my list right now, what's the first number, or the lowest, or highest on my list, lowest on my list, I guess, that is the same for both of them? Just looking at these 2 examples, it's hopefully obvious to see that 60 is a multiple of 12. 60 is also a multiple of 10, and it's common to both of them, and it's the smallest. There's nothing below 60 that I can include, and there's nothing below 60 I can include here. So the LCM of 12 and 10 is 60. There is no smaller multiple. So that was the first method we dealt with. That was kind of the easiest. The problem is when I run into something like, okay, what is the LCM of 17, 23, and I don't know, 71. That's going to be a bit cruel. Let's pick something a little bit nicer. 74. Now, I could count by 17. I could go, we have 17, then we have 34, and then we have, 40, 51. I could just keep doing that, and I could do the same thing with 23. You get 23, you get 46. 23 times 3 is going to be 69. And I could do the same thing here. 74 is 148. I guess I should write 74, 148. I could keep going. But those numbers are going to get really big, really fast, and then finding the common one between all of those is going to be tricky. So is there a different way to do it? Now, this is kind of the method that everybody forgets. But the good news is, if you're on a provincial exam and you don't remember how to do the prime factorization to find the LCM of your numbers, then you can just write down the multiples. And I forget who was in on Wednesday last week. We were finding the LCM. And for something like, what was our big number here? 74. If I go 74 plus 74 and just keep hitting equals on my calculator, it's just going to keep on giving me multiples. So 74, and then I hit 7 plus again, and I keep hitting equals, and it's going to start counting by 74. So I can just simply write these numbers down, and I could figure out what's common to all of them. There's nothing wrong with that. It's kind of like a brute force method. It's going to take time, and we don't always have tons of time. So on a provincial exam, if I didn't remember how to find the LCM, I would write a little star next to the question. I'd come back to it at the end. Be like, I don't remember how to use prime numbers to find it, but I know I can do it just by, finding all of the multiples until I get something that matches in all three lists. So, sorry about the long and the short of that. The second method is use prime factorization. And what I'm going to do is, this was the method number 2 I'm referring to here. So this is the faster way to do it. If I can find the prime factors of my 3 numbers, if I can take the greatest exponent of each of the numbers and multiply them together, that's going to give me the least common multiple. And this can be really a really big number. So the example we included in the course was 28, 42, and 63. We found the prime factors of them, and then we found the greatest exponent that each prime factor had. And then we multiplied those together. So you can see that the first one I had 2 squared times 7, then the second one I had 2 times 3 times 7, and this one I had 3 times 3 times 7. What factors did I have? Well, I had a 2. The greatest exponent of 2 was 2, so I included that. Then I had a 3. The 63 had 3 squared, so I included that. And then I had a 7. And if there was other factors that included, I'd include those as well. So let's maybe see if we can figure out the LCM of these 3 numbers here. Of course, I just arbitrarily pick these. Likely will not work out quite as nicely as the one in the class did. But let's see what we can do. 17. Is that a prime number? Does anything go into 17? No. So 17 is prime already. All right. 23. Did I pick 3 prime numbers? This is definitely the worst question I've ever thrown together. 23 has no factors. It's prime. I'm thinking 74 has no factors as well. That was probably the worst example I could have. What's 74? Factor of 74. Oh, 2. Sorry. 74 is 2 and 37. All right. Anything going to 37? No, it's prime. Well, this is possibly the worst example I've ever created on my feet, but we'll go with it. So the greatest, what are all the primes? 17 has 17, 23 has 23, and this is 2 and 37. It just kind of works out that if we want to find the least common multiple, we're going to have to take 17. The greatest exponent of that is 1, so I just leave it out. And then I'm going to multiply by 23 with a 1. And then I'm going to multiply that by 2 and a 37. So basically I'm just multiplying the three numbers together. Because the first two were prime, it's going to be a big number. So 17 times 23 times 2 times 37 is 28,934. You could see if I just did the brute force method by writing down multiples, I would have been there for a while, assuming I had to keep writing down multiples of 17 until I got to 28,000. Now, this was just a question I just made up on the spot, so it did nicely. All of the questions, I shouldn't say all of them, the majority of questions you get on your provincial exams will have a sort of solution that's kind of nice and makes you, understand the math a little bit, but just bad choice of examples. But hopefully you understand the method, the two methods. You just write down the multiples, count by 17, count by 23, until you find the same number in all three lists. Or you can find the prime factorization and take the greatest exponent of each factor that kind of shows up. So that's kind of the trouble we run into when we do stuff like that, just think on our feet. But the example in the class was probably a better one because it was intended to work out properly, and hopefully it did. All right, the idea here is that you guys have learned everything and it's up to you to review. So some really good ways to review would be to go onto the Ministry of Education website, find some old exams, and go through them. Figure out the questions you don't understand. Say, okay, this question was from Unit 2, I need to go back and review Unit 2. That's one great way. Second way, not as great, but the course has a final exam review guide, which you need to do anyways, so you might as well go through that and say, okay, Unit 1, I need to learn this, and Unit 2, I need to learn this and this and this. I don't love that method because the learning guide from the course doesn't include everything, it's just kind of snapshots. And the other thing that, it might seem kind of a little bit iffy, but the final review learning guide, it's all broken down by sections. When you write your final exam or the midterm, you're not going to know what section anything's from, which makes things harder. It doesn't seem like it could be that big of a deal, but if I come to a question and it's just a bunch of polynomials and I'd like, oh, am I solving the system? Am I, factoring this? Am I graphing it? What's going on? It just depends on which section it came from. I mean, the question will be explicit as to what it wants you to do, but just looking at it, you might not automatically remember that it's from, Unit 4 or Unit 5. So just be careful with that. Don't rely on this learning guide to review for the final because that's not going to be adequate. Old provincial exams are great because just like the quizzes and the tests you do in this course, old provincial exams will recycle questions. They'll use the same image, they'll just give it different lengths, or they'll use the same question with different numbers. It happens. They don't, there's only so many things we can ask, so it's not like they're just gonna come up with, brand new test every time. They're gonna take some of the old stuff that they already had in their test bank, give it a few extra tweaks, little number here, little number there, and give it back to you guys again. So the more exams you have a chance to go through, the better off you'll be because you'll be exposed to more types of questions. I see somebody had a question here. Do we have time to go over what you're talking about before with 1 times 15 and 1 plus 15 because I couldn't remember that? Oh, that was from factoring trinomials. Now I'm going to try to think of a trinomial that we can factor here on the spot, which might not work very well because they don't all factor. Let's say I had x squared plus 5x plus 6. No, 6 doesn't work. Multiply 6. Yeah, that'll work. Okay, so it says factor. I bet you do remember it, Abby. It just maybe wasn't clear enough. That was the question. Factor this guy. So when I factor a trinomial, I need to figure out numbers that multiply to the last one and add to the middle. So I need factors of positive 6. So factors of 6 are 1 and 6. I could also have 2 and 3. So 1 plus 6 is 7. That's not the one. 2 plus 3 is 5. So that is the one I want. These are the factors I want because they multiply to 6 and they add to 5. All right, so we haven't done factoring for a while. So what I would do was, there's kind of two ways I could break down the middle term. Because there's nothing in front of my x squared term, I could just say, okay, I have x plus 2 and x plus 3. So remember, if I'm moving down my page, I am factoring. If I'm going back up, I am multiplying. These things are opposites of one another. So if I wanted to check my answer, I could, instead of factoring, I would multiply. So I'm going to FOIL. First outside, inside, last. X times x, x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. So I'd have x squared. Combine my middle terms. 5x plus 6. Is that what I started with? Yep. There we go. All right. So obviously that's something that you're going to have to go back and refresh your memory on because you probably haven't done a lot of factoring between now and Unit 4. So I'm going to leave you guys there. First priority is finishing off your unit tests, which means for some of you submitting your learning guides for other units. Once you've finished off your unit tests, which are very important to get done now that we only have 2 weeks left, then you can go and start reviewing for the final exam, which means the final exam review package from the course. That's going to be due next Monday when you guys come to sit and write the exam in the gym. So that's kind of the second thing you need to do. So once you've gone through the final exam review package from the course, then you can start looking at old provincial exams, things like that. So this learning guide is 10 pages long, should take you maybe a couple days to get through if you're working hard. I'll spend tomorrow and the next day going over stuff from the final review learning guide. And then on Thursday's class, I will go over an old provincial exam, which I will upload in the next few minutes or sometime today, so you guys can start looking at it now. I'll have it up for tomorrow's class for sure. So that's kind of where we're at. It's totally up to you to get out what you put in. If you have finished everything, you're starting to review, you're going to do fine because you've done everything. The people that I'm concerned about are if you're a little bit behind, you're trying to finish up all your unit tests and then you're trying to review at the same time and it just doesn't work. So we do have 2 weeks. We have a little bit of room and then you guys just need to kind of budget out your time appropriately. I don't want you to spend every day doing math for 3 hours, but provincial exam is significant and you guys should put in some effort. The more time you spend, the more you're going to get out of it likely. So just consider that. We have to do the midterm review and the final exam review. The midterm review and the final exam review are the same thing. So it's just this one learning guide. This is for both the midterm number 2 and the final exam. It's the same document. It's only one. We're done the course, so this is it. This is all. So yeah, this is due next Monday. So it gives you a week to finish off 10 pages, which is about the same as what we've been doing. So hopefully that clears that up. We'll start looking at provincial exams at the end of the week, and then next week we'll spend more time looking at provincials. So I'll leave you guys there, and hopefully you guys can get the Unit 8 learning guide submitted, which a bunch of you have already, and get the Unit 8 test underway. Last question, will we get our midterm score back? Yeah, I'll have it for you likely on Tuesday next week. I'll probably mark them all day on Monday. So yes, I will make sure you get your marks back. All right, thanks guys. We'll see you tomorrow. Have a good afternoon.